Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to continuity as it relates to calculus. So hopefully you understand by now continuity means no disruptions, right? So when we're graphing, I don't know if in art your teacher ever had you like make a picture where you just keep going and your pencil can't pick up and you just keep making a picture. That would be a continuous picture. Obviously in calculus we're not having graphs that just look like scribble marks, but that idea of continuous is happening. So you might have like a function of a polynomial that just kind of keeps going on and on and on and goes forever. So anytime you need to find the limit, it will be the same as just substitution. So that's not a problem there, okay? Or you could have some other types of continuity. So here we see a function with a removable discontinuity. This one was continuous, right? And the reason it's a removable discontinuity is, let's say this is point A. So the limit as x approaches A from the left for our function will equal the limit as x approaches A from the right of our function. In other words, our fingers come together. So it is discontinuous, but it's a fixable or removable discontinuity. We would know where to fill the hole in. The other kind of discontinuity is a gap discontinuity. So you might be going along, maybe you have a piecewise function, and it might graph like this, creating this gap. So a gap discontinuity happens to have when x approaches A from the left, it does not equal the limit as x approaches A from the right. And you can't just fix that with a little bubble, okay? So the reason why we had to talk about continuity is to talk about a very big theorem. Now, the good news is that you have been using this next theorem for a long time. So it might just seem like, really, you're doing what? So keep that in mind, okay? The intermediate value theorem. Okay. Here we go. Fasten your seatbelts, right? Whew, big words. If f, that means your equation. Why are we blurry? My camera loves me today, let me tell you. Sometimes if I add another object. Don't ask me why. If f is continuous on a closed interval, and they're going to give us our interval. Okay, so what that's saying is between this x and this x, your function is continuous. Meaning there's no gaps, there's no removable discontinuities, it is continuous. And n is any number between f of A and f of B. Okay? Then there is at least one C in A to B such that Should have called this K. Forgot that I wanted to call it K. Such that f of c equals K. What the heck is that saying? And how them, like, Michelle, come on. We've used this before? Absolutely you have. So let me get to it and then I'll explain even further where you've used it before. So we have something going on here, right? Closed interval A to B. I need to move B out just a bit because I ended it right there. So we'll put B there. Okay, there's our closed interval A to B. Okay, therefore this would be f of A. And this up here is f of B. Then, and K is any number between those, so we'll make K right here. Ah, there's our C value. Okay, so when have you used this? Well, normally, you're going to go ahead and look at a graph like this. And let's go ahead and let's find why we might have looked at this. Let's pick, in this particular instance, A is 2 and B is 3, right? So our closed interval is going to be 2 to 3. So here's our f of A, and here's our f of B. And I want to pick a K value of 0 because it's between there. Hey, a 0 exists, right? That's when you've used the intermediate value theorem. You've used it to say, hey, because f of A is below 0 and f of B is above 0 and it's a closed loop, we have to have a 0 in between. Okay, so because of this intermediate value theorem, if f of A is below 0 and f of B was greater than 0, then there must be a f of C equaling 0 such that C is between A and B. You have used this before to say, okay, well, let's look at the graph right here. We can see that this is below, we can see that this is above, and it's continuous, so we had to cross 0. That's all the intermediate value theorem is saying, but it's such a powerful thing. You've been applying it for years without realizing it. But that's all you need with the intermediate value theorem. However, occasionally in calculus, you're actually going to have to state that out. But calculus is kind of where we talk about all the rules that we've been using and why we've been using. Can you do this if you don't have a continuous function? No. Because if it's not continuous, there could have been a huge gap and we could have skipped 0 or whatever K value is picked. So for the intermediate value theorem to hold true, you must have a continuous function, which is why we started this video out with talking about continuity. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.